This is the first video on Chapter 48, Solids of Revolution and Volume. And Theorem 355 is based on Theorem 351 from Chapter 47. And what we're doing here is we have this region from x equal a to x equal b, and we're looking at the region under the curve first of all. Now what we already know is if we want the area of this region, we just take the integral from a to b of f of x dx. But what we're doing in this chapter is we're taking this region and we're spinning it around the x-axis. Okay, so we're spinning this around the x-axis. It makes a three-dimensional solid. And we take a cross-section right here at x. And what we learned in chapter 47 is if you want the volume of the solid, you integrate from a to b of the area function. If we spin this right here, what happens with this line? It makes a circle. As we're spinning this around the x-axis, as we revolve this around the x-axis, we have a circle right here of radius f of x. And so the area at x is pi r squared, but what is r? R is f of x, so we have pi times f of x squared. This is our area function that we can compare with our area function in chapter 47. And so how do we get the volume? Well, we integrate from a to b of the area function, but the area function is pi times f of x squared. So that's what we're doing. We revolve this around the x-axis, and we want the volume of the three-dimensional solid created. We integrate from a to b of pi r squared, or pi times f of x squared. And so we're going to look at example 356b. Part A is just finding the area, so we won't go through that. And we'll look at example 357. Example 356, we have our function y equals square root of x plus 1, which is a square root function shifted up 1 unit. And it's bounded from x equals 0 to x equal to 9. Substitute 9 in here, we have 4. So this is the 0.94 right here. Doesn't really matter, but it's nice to note. And now we'll integrate from 0 to 9 of pi times f of x squared. So we have the square root of x plus 1 quantity squared. I want to remind you that this is not simply x plus 1. We have to FOIL this term. So we have x plus 2 times square root of x plus 1. So we're going to integrate this function. We just reverse the power rule. So we have 1/2 x squared plus 4/3 x to the 3/2 plus x evaluated at 9, evaluated at 0, and subtract. We have 171 pi divided by 2. Again, do as I say, not as I do. If you're doing a problem like this on an assignment, I want to see the work. I want to see you substitute 9, substitute 0, subtract. So I've skipped a step here because I'm out of board space. So I did that to save board space. But I will expect you to put that step in. Example 357 is similar, actually a little bit easier. The function we have is a square root function from 0 to 9. Square root of 9 is 3, so this is the 0.93 right here. Integrate 0 to 9 of pi r squared. R is f of x, so we just have pi times f of x squared. The square root function squared is simply x. So we're just integrating 0 to 9 of x. Antiderivative is 1/2 x squared. Substitute 9, we have 81 pi divided by 2. Substitute 0, we have 0. So we have 81 pi divided by 2 minus 0.